Hey there, fourth grade. This is Mr. Campbell. We're going to be working on page 361, and this is lesson 9.8, adding mixed numbers. Now, we started working on this in 9.7, where we were using our models to show how we can add these together. But today we're going to keep working on that and say, I can use equivalent fractions and properties of operations to add mixed numbers with like denominators. All right, so all that means is that when we have fractions that we can add together because they have the same denominator, all right, we can also use what we know about addition, some of the properties of that, which is that we can add in any order we want to. So we're going to take a look at what does that look like when we're actually doing the math with adding mixed numbers. So would you go ahead and turn with me to page 362? All right, here we are on 362. I'm going to zoom us in a little bit. All right, and let's go ahead and see what it says. Brenda mixes sand with 2 7/8 cups of potting mixture to prepare soil for her plant. After mixing them together, how many cups of soil does Brenda have? All right, so she's got this sand over here, and then she's got that she was adding in her potting mixture, right? It says you can use the properties of operations to add mixed numbers. When you break apart a mixed number to add, you're using the commutative and associative properties. And we talked about those much earlier in the year, and also last year in third grade, we talked a lot about that. So that's what we're going to be working on, is breaking these apart. Well, let's look at that in box B. So box B right here, it says, so find 2 7/8 plus 1 3/8 by breaking up the mixed numbers. So what do? We take the whole numbers and add those together. And this parenthesis just means we're going to do that together. And then we're going to take our fractions and put them inside of a parenthesis over here. It looks really complicated, but all it's really telling us to do is just separate these into some different parts to add them a little easier. All right, so we can add our fractions together first. So 7/8 plus 3/8. Well, we've got that common denominator here, so it's going to stay 8. And that means we can just add our two numerators. Well, what's 7 plus 3? 7 plus 3 is 10. So I have 10/8, right? Now I can add the whole numbers. 2 plus 1 is 3. And that 10/8 comes with it, right? Perfect. So there's our answer. But I see that my numerator is bigger than my denominator. And if my numerator is bigger than my denominator, then this is called an improper fraction. And I need to break it apart and take out the whole. So 3 10/8 can be broken apart into 3 plus, well, if 8 is my denominator, I'm going to take 8 out to make one whole here. And then if I took 8 away from this 10, I'm left with 2/8. Because if I add all this together, does it still add up to here? Well, 8 plus 2 is 10. 8 is my denominator, and 3. Yeah, that still makes sense. Well, 8 over 8, we've talked about before. When my numerator is the same as my denominator, that's one whole. So what's 3 plus 1 is going to be 4. And then I have 2/8 coming over here as well. All right, so that's how we can also kind of break this apart and make this make a little bit more sense. All right, well, let's go ahead and check out box C. Now, if this makes sense to you to add our whole numbers together and add our fractions and then figure out if we need to take some out, stick with that. That can make sense. The second way I'm going to show you, it makes sense to some people, and that is fantastic. But some other people feel like it's just a lot more steps and they don't love it, and that's okay. All right. So let's take a look at what we've got. We've got the same numbers, so 2 7/8 plus 1 3/8. All right. So we're going to take our 2 7/8 and break that apart into 2 plus 7/8. All right. But now what we're going to do is we're going to take this whole number and make it into a fraction. And the way that I do that is that I take my denominator and times it by the whole number, and that becomes my new numerator. So 8 times 2 is 16, and I'm going to keep that same denominator. All right. Then I'm going to add 7/8 to that. So 16/8 plus 7/8. Well, 16 plus 7 is 23, and I keep my eighths. So here's my new number. I took 2 and 7/8, turned it into an improper fraction, which is 23/8. These are the same. These are equivalent, is what we call that, right? I'm going to do the same thing for 1 and 3/8. I broke it into 1 plus 3/8. My 1, I took 8 times 1 is 8 and kept the denominator. And then I'm going to say, well, 8 over 8 is equal to 1. But when I plus 3, 8 plus 3 is 11 and keep that denominator of 8. So we've got 11/8. Now that I've done all of that, I can say, okay, well, I've got 23/8 plus 11/8. 23 plus 11 is 34/8. All right. That's my improper fraction. And what's crazy is 34/8 is equal to 3 and 10/8 over here. They're just written differently. All right. But I want to turn that into a mixed number. So now I'm going to try to start with my 34, and I'm going to keep taking out 8 from the top to make whole numbers. All right. So 34 minus 8, there's one whole. Then I'm at 26 minus another 8 is 18. 18 minus 8 is going to be 10. 10 minus 8 is 2. So this is 1, 2, 3, 4 whole numbers because I could take those out of here if I keep subtracting 8 away from my 34. Now, just to show you real fast, because that might have been like, wait, what are you talking about here, Mr. Campbell? If I had 34, every time I have an 8 over 8, I'm going to minus 8 from here. So 34, that's my numerator. 34 minus 8. Well, that's 26. All right. So that's where that 8 came from. All right. Now I can minus another 8. All right. 26 minus 8 is 18. I can minus 8 again. I'm just going to keep going until I can't take away any more 8s. So that'd be 10. I can minus 8, and that would be 2. All right. Each of these is a numerator, right? So this came up here to be an 8 over 8. This came right here, the second one, 8 over 8. This came here to be my third 8 over 8. This came right here to be my fourth 8 over 8. And my 2 here is all that I'm left with. All right. And the reason that we can do that is then we can turn each of these into one whole. Because whenever I have the numerator and denominator is the same, then I can add them. So 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 2/8 is 4 and 2/8. Now again, some people love this way, and they're like, oh, that makes so much sense to just make it all fractions and then be able to do it. Others really like over here, where you're just like, I like the simple part of just adding the whole numbers, adding the fractions, and then changing if I just need to do, a little bit of improper fractions. That's okay too. Whichever of these two ways you like the most, stick with that, okay? Don't get too complicated as we're working. But let's go ahead and turn to page 363 and look at what this is going to do when we're working on some problems over there. All right, so here we are on page 363. Now, I grabbed some scratch paper. Sometimes I use whiteboards. Other times I just get extra pieces of paper because I'm going to want a little extra room to write when I see I've got some work on here. And if you ever noticed, like on the assessments and the tests that we give, we always try to give more space than what they've got in here. That's just so we can try to help you out. Well, we're going to do 3 problems together, and then I'm going to have you try 3 on your own in just a minute as well. We're going to start off with number 3. All right. So for number 3, I've got 1 and 7/8 plus 1 and 2/8, right? All right. Well, when I see a problem like this, I'm going to start off. I personally just really like adding the whole numbers and then the fractions. So that's what I'm going to go ahead and show you. If you're liking the other one where you convert it into an improper fraction, that would be a really good thing to talk with your teacher about and see if they can walk through, make sure you get all of those correct. All right. So when I'm writing over here, I would love for you to grab some paper and write it down with me so that way you're practicing at the same time I am. That's what's going to really help you to do this work independently. If you just sit there and don't do anything, you're not really going to be learning a whole lot from this, okay? So it's important for you to practice by getting some paper and writing it down, or if you have a whiteboard, you can do that too, All right. I'm going to start off adding my whole numbers together. So 1 plus 1. Well, what is 1 plus 1? It is 2. All right. Now that I've added my whole numbers together, now I'll add my fractions. And I see they have a like denominator of 8. So I'm going to start off writing that in here. All right. That's my denominator that I'm going to be keeping. Now I can add my numerators. 7 plus 2. 7, 8, 9. Right? Now, before I'm done, I need to ask this question every single time. Is my numerator, the top, bigger than the denominator? And I look here and I go, it sure is. 9 over 8. So what do I need to do? Well, I need to take my 9 and see how many times I can minus the denominator, which in this case is 8, how many times I can subtract this. So 9 minus 8. 9 minus 8 is 1. All right. Can I subtract another 8? No. So the numbers that I have here are 8 and 1. So this is going to be 2 plus 8 over 8 plus 1 over 8. The numbers that I'm left with over here are what I've got. When I can subtract that 8, that's what goes in my numerator. Whatever's my leftover is my other numerator. All right. Well, 8 over 8, we know we turn into a 1, which is now another whole number, right? 2 plus 1 is 3, and then I need to plus 1/8. So that would be 3 and 1/8. So over here, I'm going to write 3 and 1/8. All right, that's how we can solve this mixed number. All right, let's go ahead and try number 5. All right, try number 5. I'm going to go ahead and slide this up so it's kind of out of the way. Give me some extra space here. And I've got 4 and 2/3 plus 1 and 2/3. All right, so I'm going to start with 4 and 2/3 plus 1 and 2/3. I'm going to add my whole numbers first. So 4 plus 1. 4 plus 1 is 5. Now I can add my fractions. 2/3 plus 2/3. Well, my denominator is going to stay 3. And then 2 plus 2 is 4, right? Ooh, I can see that I can break this apart into 3/3 plus 1/3, right? Because 3 plus 1 is 4. 3 over 3 is a new whole number. So then I can change that to 5 plus, I'm going to turn this into one whole and then still add my 1/3. 5 plus 1 is 6, and then that 1/3. So 6 and 1/3. Okay, it's kind of the same steps of what we were doing before. I'm going to write that in over here because I want my teacher to be able to see the work that I'm doing. And then again, this is why having a piece of paper is really helpful, because if Miss Benner, Miss Hanley, or some other teacher walks by and says, hey, what are you working on? I can always show them all the work I've already done, right? Then they know, oh, hey, you're doing a good job. You're working hard. All right. So we've got those two. Let's check out our final one. I'm going to slide down a little bit. All right. So our final one that we're going to work on together is going to be number 7, 2 and 1/3 plus 2 and 1/3. And for this one, I'm going to go ahead and just use the space over here because I see I've got a little extra space. All right. So I'm going to start with my whole numbers. 2 plus 2 is 4. 1/3 plus 1/3. 1 plus 1 is 2. And my denominator stays the same. Do I need to simplify this? Is this an improper fraction? No, my numerator is smaller than the denominator, so that is the answer. I'm done. 4 and 2/3. All right, I added those two whole numbers, I added my two fractions, and that's what I ended up with. All right. How about up here? I'm going to have you pause the video in just a moment, and I want you to work on number 4, number 6, and number 8. All right, I want you to try those 3 out. And then we'll go over it. So pause the video right now, do those 3, and then come back to check your work. All right, I hope you paused your video. I hope that you were able to solve these problems. Let's start with number 4. So 2 plus 5, I start with my whole numbers. 2 plus 5 is 7. And then I've got 4/10 plus 5/10. Well, my denominator is going to stay the same at 10. 4 plus 5 is 9. Do I need to simplify this? 4 and 9/10? No, that is good, right? My numerator is smaller than the denominator, so it's simplified. All right, I'm going to go ahead and put my equal sign over here because sometimes that's how I like to solve as I'm working. For number 6, 6 plus 4, well, that's 10. And again, I hope you already solved these and you're just checking your work right now. I've got 5 twelfths plus 11 twelfths, so my denominator is going to stay 12. 5 plus 11 is 16. Uh-oh. This is an improper fraction. My numerator is bigger than that denominator. So rather than writing this whole problem out over here, I'm just going to solve this piece. All right. So I'm going to write 16 twelfths. And so if I were to minus 12 twelfths, because that's one whole, if I were to take that out of here, 16 minus 12 would be 4 twelfths would be left over, right? So if I took this, this would be like me saying 16 twelfths is equal to 1 whole, because I took that out, and 4 twelfths. Okay, I hope you're tracking with me. So then if I had 10 whole still left over here, and I'm going to add 1 and 4 twelfths, 10 plus 1 is 11, and then 4 twelfths, my answer should be 11 and 4 twelfths. All right. And as I look at this one, do you notice my 11 isn't that much bigger than my fraction? So I need to make that a little bit bigger. And the reason for that is that when we're looking, our whole number should be the same size as the way that we write the whole fraction. Okay. And that just helps us to be able to see where our whole numbers are versus what is a fraction. All right, number 8. I'm going to start off adding my whole numbers. So 1 plus 2 is 3. All right. And then I see 12 is my denominator. And then 9 plus 5 is 14. Uh-oh, I got another improper fraction here. All right, so I'm going to write out my fraction. So 14 twelfths, right? I want to take out 1 whole, which would be a 12 over 12. So 14 minus 12 is 2, and then 12 stays the same. So this becomes a 1 whole, and then my 2 twelfths comes over here next to it, right? So I took my 14 twelfths, and I turned it into 1 and 2 twelfths. So 3 plus 1 and 2 twelfths. 3 plus 1 is 4. And then I'm left with that 2 twelfths. All right. As I went over these, I'm hoping that you already solved them and you're like, oh yeah, that's exactly what I got. That's how I did it. Because this is just how we solve these multi-step problems when we're working on mixed numbers. All right. I hope that you guys are going to feel really confident finishing up your independent practice. Make sure you check in with your teacher to see which problems you're going to be working on. Have a great rest of the day, and we will see you next time.